Welcome back. Mr. Gritto here. So the purpose of this lecture is to help you organize the different groups of the periodic table. So figure out how the periodic table is organized a little more. Alright. So last lecture was lecture 1. We talked about metals, nonmetals, and metalloids and their properties and how the periodic table came to be. Today we're kind of going to focus on not only how it came to be, but how we can classify those groups even more. So we're going to create subdivisions of the nonmetals and also the metals. The metalloids get to stay the same. They're that weird, funky group. That'll be fine. So if you're following along, you should be using Lecture 2 notes. So Unit 4, Lecture 2. It's on. We're also going to be using the website ptable.com. Oh, wrong one. Just checking on Lecture 1. ptable.com. Great website. It's a cool thing. So, back to the slides. Nope. I'm great at this. So, what we want to do first is talk about what you can tell from a block in the periodic table. Alright. So down here, I've got to pull down a block of the periodic table. So this is sodium. And I've also added its Bohr model of an atom down here. So remember, the Bohr model is not the most up-to-date model, but it's a good one to see the correlation between the block in the periodic table and the properties that the elements actually have. So I have my kids do is I have them look at the block and I have them look at the Bohr model and try to see similarities between the two. So you can pause the video now and check out the similarities. Try to see as many connections as you can between the numbers in the block, the symbol, and the numbers and dots on here. And try to think about what they mean. So assuming you've paused your video and figured out all your tricks, let's go over them. Alright, so the first thing I like to point out is this 11. Now, the 11 we know is the atomic number, which is the number of protons. We see the 11 here, and we also see it in the center. So our nucleus of our Bohr model down here, 11p. So we know this element typically or always has 11 protons. Sodium always has 11 protons. So that's where the 11 comes into play. Our next numbers are over here, 2, 8, and 1. If I add them up, they add up to 11, which is the same as this. So it could be the protons, but they're not. If we look over here, 2, 8, 1, the 2 corresponds to the 2 dots on this first energy level. On the second energy level, there's 8 dots. So there's a 2, 8. And on the third energy level, there's 1 dot. And that's where the 2, 8, 1 comes into play. They're the electrons. So these numbers are the same. 2, 8 plus 1 is 11. And this is 11 protons because your protons and electrons will be equal in a neutral atom. But the 2, 8, 1 tells you how many electrons are on each energy level. 2 on the first, 8 on the second, 1 on the third energy level for a neutral atom of sodium. Now there's nothing Na on here, just 11 protons means it's sodium. Gives you the name 22.99. There is a connection between this average atomic mass number, or average atomic mass, and this model over here. If you figure it out, it's if you add the two numbers here, 12 and 11. 12 plus 11 is 23, right? I almost said 13. Ooh, that was close. Is 23. And that's going to be our mass number. So mass number is different than average atomic mass, right? Mass number is just for a single atom, how many protons plus neutrons there are, because these are the two subatomic particles of mass. Where average atomic mass is over the scope of all the isotopes of sodium. On average, if you had all those elements together, the average mass would be 22.99. So I mean, they're really close for sodium. So typically, the most common isotope will be the average atomic mass rounded to its whole number. So 22.9 rounds up to 23. So there's some correlations between the symbols and the Bohr model that I think are important to be able to see and recreate for yourself. So, in general, what can we learn about the elements square in the periodic table? A lot. But we can also see this diagram. So we have atomic number, electrons in the energy level, the element symbol or chemical name, or chemical symbol, chemical name, element name, and the average atomic mass are typical things you'll see on the periodic table. Usually, like the bare bone periodic tables at least have the atomic number and the average atomic mass, and the symbols, obviously. So, what we want to focus on today is one, what you could read from the blocks, so we've talked about that, and two, how our modern periodic table is organized based on periods and groups and what periods and groups kind of are. So your periods are going to be your rows in your periodic table. So the horizontal rows. So hydrogen, helium are in the first period. 1, 2, 3, 4. Potassium, calcium, scandium, and so on until krypton are in the fourth period. So if I ever tell you that you're looking for an element in the third period, you'd have to tell me one of these 8 elements. Sodium to argon, right? Because that's all in the third row, the third period. Now, if periods are the horizontal, the rows, then groups, also known as families, are the columns, the vertical groups. Alright, so, and that's going to be one of the more important things in the periodic table, the vertical groups. One more thing about periods, they correspond to the energy level. So hydrogen's biggest energy level is the first energy level. Cesium has 6 energy levels typically, or always, yeah. Unless it's an ion, but not there yet. Alright, so periods horizontal corresponds to energy level. Groups are vertical, and they group them, just like the triads from before, based on similar chemical and physical properties. Now, if we're talking about groups, I want to go to ptable.com, because that is an excellent website for that. So, if you're on ptable.com, it's very interactive, it's very cool. So if we want to see all our metals, we could highlight metals and it would highlight them all for us. Non-metals highlights all the left side of the periodic table. But let's look at some of the groups that we want to know. The first group on the left that we want to know is known as the alkali metals. And these are extremely reactive elements. They're all very reactive. Francium is the most reactive, barely reacting with air and things like that. Sodium, we watched a cool video of how it kind of catches fire in water and explodes in a nice burst, right? Next group we're going to talk about is the alkaline earth metals, and they're just the second column, so column 2 in the American periodic table. There's 2A in the British version, and yeah, so 2A, that's the alkaline earth metals. On the other side of the periodic table is probably one of the most important groups of the periodic table, the noble gases. Now, these guys weren't discovered for kind of a long time compared to the other elements because they're extremely unreactive. They're very stable. They don't react to anything else. They're happy by themselves, hence why they're noble. They don't really need anyone else. They're good on their own. And the noble gases are what other elements are going to strive to be like. We'll talk about that later. That's a good group to know. Group 18, the noble gases, 8A in the British model. Halogens, a group right next to the noble gases, fluorine, chlorine, bromine, iodine, and crew. And you still have your metalloids. These are like lightish green color right here, which separate the metals from the non-metals. They're kind of always going to hang out together. Below the metalloids, you have a weird group, which is known as the other metals or the weak metals, which they're metals, but they don't have the best properties of metals, because it makes sense because they're kind of transitioning towards being non-metals. And you have 2 big groups over here. You have the transition metals, right, which are metals that we typically think of when we think of metal. If I think of a metal, I'm thinking of like silver, gold. I think of iron more often, I think, yeah, which are all in this group. So here's iron, silver, gold. Mercury's a pretty cool metal. Don't touch. It's, yeah, Mad Hatter disease. It's kind of cool. But you also have down here what's known as the inner transition metals. So those things that we pulled out of our periodic table are the inner transition metals. And they are the more heavy radioactive guys. So you have uranium down here, plutonium, all those really cool elements for radioactivity study. Those are your main groups that you want to focus on for the different elements. Your metalloids, so still remember that from before. Your alkaline metals, alkaline earth metals. Noble gases, halogens. Still have your non-metals, your non-metals up here, and your metalloids. Those are the groups you kind of want to know. Focus on the ones that are in columns. So like column 1 is alkaline metals, column 2 is alkaline earth metals, column 17 is halogens, 18 noble gases. Alright, so be ready to identify if I ask you cobalt, atomic number 27, is in what group. Be ready to tell me that it's part of the transition metals. Alright, so that's the main topics from lecture 2. Post any questions you have in the comments or ask me in person. All right. Have fun. Where's the stop button?